Hello and thank you. Yeah, it's working. My name is Prykhodchenko, and I'm pretty glad to see so many people who are developers and not afraid of the infrastructure here today. Well, probably that has to do something with the wine that give on the restaurant, but we'll try to get to get the way around the infrastructure management that does not require consumption of any kind of wines or alcohols. So, as I said, my name is Prykhodchenko. I am a cloud engineering consultant at Tech, and today I'm going to talk to you about Python-friendly infrastructure management. And by friendly, I mean that it should be friendly for developers, and you'll see why. So I spent over a decade working as a Python developer myself, working mostly in the field of automation and infrastructure management. And I've been hearing this statement a lot that developers avoid infrastructure. I had been biased all the time. I've been working with the infrastructure. I loved every aspect of it. I liked the idea how you can write a software, even tiny piece of software that can manage the entire and expensive data centers. But then later I switched to site reliability and platform engineering, and then I started teaching developers how to build reliable systems, and I realized that it's actually true. And when you start talking to developers, they love coding, they love creating software, but as soon as the work starts talking around infrastructure management, it can get tricky. Developers try to delegate these jobs to someone else. They try to escape from it, in short. And I've been given that a thought about why this happens. What is the nature of this avoidance? And my biggest theory is that it's complexity. Because through the recent years, infrastructure became immensely complex and immensely complicated. And if you give it a thought and you take a look back at the infrastructure maybe even 10 years ago, that you will see that it was simple. It was very familiar with the developer's environment, and then you developers could run, you write your own software on your personal computer or laptop if you were rich back then. Then you run, you test it, you see it works locally, right? It works on your machine. Then you just copy it to the server. Maybe there are a couple of them if your organization is rich again. And then you run it there. Then it's accessible to users, and you would understand where it runs, how it runs, and how the users access it. So the most important part of it is that you as a developer would understand how to test that it runs properly on that production environment. We faced several changes in business requirements to the production infrastructure, and now it looks a lot different. Now it has many loosely coupled components. There is a lot of ephemeral stuff going on there. There are containers, serverless computers, whatever. There are different ways to do the infrastructure, but none of them looks like your typical development environment. So you as the developer now write your application, write your code, you test it locally, and then in order to put that to production to get real workloads from users, you would need to do use some sophisticated tools which are no longer in your developer ecosystem that you normally use. And then when the application is running there, you often don't know exactly how it is running, because it's not your developer laptop. It's a Kubernetes cluster with serverless components there, right? And you don't know how to test if it's running properly there. So to tackle this situation, operations people or DevOps people, you call them, there's no single conventional name in these people, they gave you a range of tools which are called infrastructure as code. And well, we sort of decided that this will solve the situation. This will solve the problem, and developers will love working with these tools because code is code, right? Like meat is meat. Doesn't matter if it's pork or beef. So like code is code. So every developer will like working with it. And then it didn't necessarily happen. So it helped a little. It helped to tackle the situation a little. But then we faced another situation, another problem of infrastructure as code approach is the isolation of developers. We somehow assumed that developers will love working with our tools that we gave them, and we didn't realize that developers work with the stack of technology they use because they love it. It's not because they are, being forced by someone to work with Python or with Java or with any kind of language. And you love working with the technology tree that you've chosen. You know the ecosystem, you know the tools, you know the editors, you know IDEs, everything. So you have your habits, good and bad sometimes, in working with within a certain ecosystem, and you don't necessarily want to change it. And if you take a look at the infrastructure as code, mostly that looks like an alien language, because that's normally, it was never Python, it was never some Kotlin or other fancy programming languages. It was some other programming language that you would have to learn, like Puppet. Well, it's based on Ruby technically, but doesn't matter. So you would have to learn it, you would have to onboard onto the ecosystem, because it's not the language on its own, it's the whole ecosystem that would have to learn. And if some of you work in bigger corporations where you have development teams, smaller development teams for smaller scope projects, then you may have seen the situation when one or more developers would be designated being a developer, the infrastructure champion or infrastructure liaison, you name it. But basically that would be a person who is designated to be onboarded into the infrastructure as code tools and do the infrastructure for the whole team. But in the talk description, I promised you to show the way how to do it not only in bigger corporation that has the capacity in the teams to designate people to do the infrastructure for them, but also in smaller setups. And why is this important? It is important because none of us is working here to write the code. Well, maybe someone is working here to write the code and getting paid for writing the code. Show me your company, I'll join. So we're not working there to write the code and that's it. We work here is to build systems. As infrastructure people, as developers, as DBAs, we work to build systems that solve business purposes and serve our customers. And there is one fundamental law of systems engineering which works wonders, and it works every time. And that law was formulated by Melvin Conway a while ago. And it states that organizations are restricted to build the systems which reflect the communication structure inside of those organizations. So what does it mean? What does it mean for us, for operations, for developers, for DevOps? That means that if we disconnect software and infrastructure, if we disconnect developers and operations, that means we will write software that is not solving business purposes effectively on the existing infrastructure, or that the infrastructure is not ready to accept the software that it is running. And this will cause tons of different issues. It could be not cost-effective system, it could be not performance-efficient system. You will have issues with upgrades. Like, there are dozens of issues that will happen if the software and the infrastructure is disconnected. And this is why when I speak to the companies, I always tell them that developers shouldn't avoid the infrastructure. And that does not mean that developers should do the infrastructure and take the responsibility for it. No, it doesn't mean they have to, but they shouldn't avoid. They should be kept in the communication circuit with the ops people and with the DevOps people, you name them, how it could be called different companies. And software and infrastructure should be built for each other. So software should take into account the infrastructure architecture it's running on, and vice versa. The infrastructure should be prepared for the software. We need to break the silos for that. To break the silos, it's always required. We always require mutual effort. You cannot break the silo from just one side. We cannot just introduce developers with the infrastructure as code tools and expect that they will use it, because the effort is required from both sides. So we need to understand how to make infrastructure as code approachable by developers and how to make them love these tools and be friendly to developers, to Python developers in this particular case. So let's take a look at the existing tools that are in the market and let's try to choose one, preferably one that is going to be easy to use and that will solve the situation for us, that will be friendly to developers. And every bigger cloud provider, public cloud provider specifically, they have their own tools. Like there is CloudFormation for Amazon. There is CDM for Google. There are also tools which are agnostic to the vendors like Pulumi or Terraform. You may have heard about some of them, and they allow you to manage the infrastructure in different clouds, even private clouds if you have OpenStack or similar software. And today I'm going to focus on Terraform from HashiCorp. So why Terraform? Terraform is a mature, industry-grade, and widely adopted software which is used across the industry by smaller and bigger companies there. And this shows up in in the friend list later, I will show you. So your typical Terraform setup for infrastructure management consists of several key components. There are manifests. Manifests is where you describe how you would like to see your infrastructure. And then there is a state file. State file describes what actual infrastructure you have, so how you want to see it and what you actually have. And then there are infrastructure providers that are designed to work with the different infrastructure providers. So then the task of Terraform is to compare the manifest and the state file and combine a set of and create a set of action called plan to make the infrastructure from what it is to what you would like it to look like. And for developers, the infrastructure management workflow is simple. You change the manifest, so you make the changes into how you want to see your infrastructure. You create the plan, and then you apply the plan. And ideally, you have your plan, your infrastructure, in the way that you would like it to be. It doesn't happen every time, of course, but most of the time it happens. So manifests themselves, they are created with the declarative approach. So again, you state what you want to see, not how to do it. Terraform decides how to do it. And normally you create them with the Terraform's domain-specific language called HCL, which stands for HashiCorp Configuration Language. And the simplest example I could come up with looks like that. So if any of you is familiar with Amazon, in this example, we create a messaging queue in Amazon SQS service. We give it a couple of parameters. And in theory, this should give us a messaging queue on Amazon. And like this presentation is not a real life scenario, right? I'm not going to lie to you that and say that it's always that simple. So this is a little piece of infrastructure from a relatively small project that I've seen recently working with one company. And it gets complicated. It gets complicated, especially when you need to create the configuration based on some conditions. And again, HCL is not Python. I've been saying that we should make it friendly to Python developers, which are familiar with Python infrastructure, with Python ecosystem. And this is not Python, it's HCL. So normally with bigger companies, I always tell, designate a person who will onboard to Terraform, because HCL is the best way to define Terraform infrastructure. There are multiple reasons for that. I'm not going to deep dive into them. But again, we're talking here about how to make it friendly for Python developers. The beauty of engineering process is that we're not talking in absolutes. An engineering process accepts compromises to build better and reliable systems. And so while HCL is the best way to define Terraform manifests, Terraform also allows developers to do infrastructure definitions in other languages with the Cloud Development Kit that it offers. Cloud Development Kit usually shortened to CDK, and it shows in the tools that I'm going to show to you later. So luckily for us, Cloud Development Kit from Terraform supports Python language. Just give me a second. And you would need to write some boilerplate project in order to start creating infrastructure, but luckily you can generate that boilerplate with the CDK-TF, which is a tool that you normally run on your computer, install and run on your computer. You get a template of the project like that. So that looks already closer to Python people, because it's Python. It's a Python class, it's some Python imports, and you may even see that one of the files is called tests. The reason for that is because you can test Terraform infrastructure using CDK and PyTest. So it's normal Python unit tests that allow you to test the infrastructure. Let's get back to the previous example. So this is the SQS queue that we created before. How would it look like in Python? So behold, it's that. So given some boilerplate that you have seen before, it was generated. We had to create an instance of the cloud provider to initialize it, the client, and then we just had to declare an SQS queue with the same parameters. You do it in a Pythonic way. Now you can use your favorite Python IDE and whatsoever. Then you can immediately see how you can use Python language features like list of strings to generate several queues, and you don't have to think about how to do it in HCL, how to do it in the Alien technology. So once we're happy with the manifest, we can run cdktf plan to create the set of actions required to create the infrastructure. In this case, we had no queues, so Terraform is trying to tell us that it's going to create 2 queues. I trimmed some output because it's a little bit wordy. Once we're happy with the plan, we run cdktf apply. You can see it takes a little bit of time to create these queues because it requires communication with real cloud provider, but then later when it's finished, you have the queues in your Amazon SQS web console. And if you deep dive into that, you can see that here we set up the tags that we have been setting up in the code. But then you ask me, Roman, but again, this is all great. How do I know how all these different classes are called? What parameters they accept? And this is the beauty of Terraform's maturity. It's mature, it's widely adopted, so it comes with extensive and very well-structured documentation. This is called Terraform Registry. It has all the providers. It has beautiful search there. You can just go and enter the name of the resource you want to create. You switch the language examples to Python, and you get all the Python examples for you. You also get argument reference and attribute reference, which help you to tell what attribute to set. But frankly, I never use this search. The wide adoption of Terraform causes that if you enter Terraform and then the name of the resource you want to create into the search, you will get it. You will get it fast. Well, you see. Does it take the complexity away? I reckon it doesn't. It allows you to create resources in Python. But then if you take a look at a simple platform to run applications on, Kubernetes is a popular one, you would have to create 40 configuration changes just to create one small production-grade Kubernetes cluster on Amazon. For you as a developer who writes manifests in CDK, that would mean you would have to create at least 40 IAC definitions. And we haven't started deploying yet, so we just create the platform. And how would you know what is the best combination and the default values for a production-grade platform? You would have to onboard onto the infrastructure management completely. You don't have to. With Terraform, you have modules. Modules are pieces of infrastructure definitions combined together, which will have same defaults and have opinionated structure for bigger chunks of infrastructure like EKS clusters, database clusters, even SQS queues. They have some patterns of being used in a good way in production. So modules provide you the way to do it right from the first attempt and not dig up into specifying 1,000 of correct parameters. So modules usually look like that. You can also find them in Terraform registry. There's extensive documentation with examples there. And every major public cloud provider has a namespace in Terraform registry. There's Terraform AWS modules for Amazon. There's Terraform Google modules for GCP, and for Microsoft, there's Azure. And Microsoft, you know, likes naming things differently. So here we go. So how do we use these modules? Like, how do we create an EKS cluster? First, we'd have to define them in our cdktf.json file. Don't worry, I will attach all the examples to in the end of this presentation, so you will be able to explore it. So we first declare what modules would you use. In this example, we use the EKS module for the EKS cluster, and VPC, that's basic networking layer in Amazon Web Services. And later, I trimmed down some of the boilerplate code, but that's the same sort of resource definition. Instead of defining individual resources, we just define these modules. So you can see there is some code here, right? But if you think about it, we create a networking layer, a production-grade networking layer, and the whole EKS cluster is going to be scalable EKS cluster with this much of the code. So for me, that's a big trade-off. It's like maybe 30 lines of code here for a production-grade, small production-grade cluster, which will be scalable in the future, and you will not have to migrate all the workloads somewhere else. Applying this takes around 35 minutes, but then it pays off with a cluster. So you have a cluster, you have node group there, you have base layer configured, and of course, you can start using it just like that. If you want to play around with the examples, you can simply scan this QR code. It will be available in the end of the presentation. You can follow by the repository. All the examples are there. They have been checked to work. And there are much more examples available on the Terraform website. I will provide all the links later. So we solved the issue of creating smaller components in Python. We solved the issue of creating bigger components in Python. But then when you start working on some product and you need to build the whole infrastructure from scratch, you might question yourself, what kind of architecture of my infrastructure should I choose? And then you start deep diving into public clouds. And you may end up in a situation that you will think that I probably need my PhD degree to get into one of those public clouds to understand what they mean by those. So do I need EKS, ECS, GKE, Fargate, or WNMATI? The letter stands for whatever new marketing abbreviation they invent. So what do I have to choose as a developer? I hope I didn't press anything bad here because I pressed something. What solutions, what basic architecture for my infrastructure should I use? And bigger cloud providers like Amazon, Google, and Azure, they saw this problem. They saw that developers cannot create their infrastructure easily from scratch. And they ended up with reference architecture documentations that they publish, that they update regularly, so it matches the current business requirement. And you may find them in Amazon or Google Cloud or Azure architecture centers, which are available by these links. You will get them later. What you need to do is to open the architecture center, search and filter your particular use case, and you will find, just a second, and you will find, most likely you'll find an example of good architecture, which is well thought, which is battle tested for your particular application. So whenever you're working on a Django e-commerce app or you're working on some messaging app, you'll find something there. So here I have a screenshot from a document for Python applications with hexagonal architecture, for Python infrastructure with hexagonal architecture, and it's very well structured. It has tons of examples, and it's ready to use for you. You can just use it. So we tackled the situation of having to write manifests in your favorite technology. We overviewed how we can create bigger chunks of infrastructure like EKS clusters, RDS clusters, and even SQSQs that sometimes need to be configured accordingly to be production grade. And also, there's a reference to the architecture. So with that, I hope you will be happy to onboard onto the infrastructure adventure with the rest of the developers. Thank you. If you have any questions, I will be happy to answer them. So that QR code provides the link to the same repository with the same examples. There is a bunch of links there, so everything I mentioned has a link. So you can go ahead and save it for yourself.
Thank you, Roman. So we have a couple of questions on Slido. The first one is, why developers have to learn about infrastructure things and write EAC, but operation learn so little about programming?
So the idea is to not have operations at the company per se, but to have a platform engineering team, which gives developers the way to build the application infrastructure within the development process. Again, if we have developers not thinking about infra and operations not thinking about development at all, we'll have a disconnected situation there where infrastructure will not be ready to host the app and vice versa. I've seen a lot of situations when developers write a lot of extra code instead of using better deployment scenario. And then supporting that code is expensive, writing the code is expensive, and then the code is bug prone. If you use it's often possible to solve business requirements without writing the code, but with just using proper deployment. And the other way around, if the ops team is responsible for building infrastructure and the ops team doesn't want to learn programming, well, we will not have infrastructure that runs products effectively. So I'm not saying operations shouldn't learn about the infrastructure. I am saying here that operations should transform into platform engineering team that will be building tools for developers, so developers can easily and conveniently manage the whole life cycle of their applications without the necessity of creating tickets or learning deeply about how the infrastructure works. Developers have to have a convenient way to do the things right from the first attempt. That's it.
Okay, thanks. So the next question is, How mature is CDKTF really? I heard mixed feedback from users about many bugs and bad documentation. Would you recommend to run it in prod?
I tried CDKTF in prod. It works for smaller teams. If you're a bigger team, HCL is the way to go. That's a simple answer. If you don't want and you don't have the capacity to onboard into the HCL, well, you will not use it. You will start creating the infrastructure manually. So on the scales, we have on one side manually managed Frankenstein monster of the infrastructure, which would have to be migrated completely soon. It happens all the time. And on the other scale, we have a not so optimal infrastructure as code that works. So I would choose the infrastructure as code that works, that is ready to scale later. It is possible to migrate from CDKTF when the company or the team grows, but it's very hard to migrate from the manually managed infrastructure when nobody actually remembers what there is to any kind of infrastructure management tool.
Okay, thanks. So next one, how do you deal with the Terraform license change? Is there something comparable to CDKTF in OpenTofu?
Pulumi is a good way to go. However, it's not that widely adopted, and I would say many developers use Pulumi. I don't use that in production. I tried it out. It actually works. It allows you to do more crazy things with the infrastructure as code because it's more software oriented, and I reckon developers should not get too creative in the infrastructure code because infrastructure code should be as simple as possible. So probably using meta classes in infrastructure management is not a good tool, is not a good idea. But yeah, like Pulumi is a good way to go. And if Terraform is not compatible with the way the company works, license-wise, yeah, Pulumi is a good way to go. It's better than manual infrastructure management.
Okay, so another question. What do you advise for testing the infrastructure? Running PyTest integration tests to test your Kubernetes cluster in the CI stage and wait 35 minutes seems not ideal.
So not all the infrastructure changes require 35 minutes, and you most likely deploy Kubernetes cluster once in a very rare while. Usually, I vouch for putting tests for the infrastructure in the same pipeline of the application deployment. So every commit, if of course that's the scenario you can afford, because if you have a service that's publicly available to users, that's the scenario you can afford. If you have a product that is being shipped as part of distributions, that process is not for you. But if you have a service that runs constantly and users have access to it, then you can even result into one single pipeline that has all the tests for the application, for the container security tests, then the infrastructure tests, and then we have deployment to staging, end-to-end tests, and deployment to production. I've seen these scenarios. So that works. And this is the way I would like to encourage developers to strive towards. It increments the ability of the company to react to incidents or business requirements faster, and it improves a lot of other business metrics.
Okay, so another question. Can you automatically audit the Terraform code for insecure configuration?
Yes, Chekhov is a good tool to use, for instance. Chekhov. I don't have anywhere to write, but please catch me up later. I will show it to you. It has a lot of patterns already there to detect if you don't create some fancy configuration, which bad people would fancy to see in your production environment. But you may also run the custom checks there. Custom tests. You can create your custom policies for a company. For instance, you want to say that every database cluster should be protected from deletion and have the encryption by default. If not, well, we don't pass to the stage when we create the actual infrastructure. But then that's one thing. Like you have to also protect the infrastructure from the other, from accidental changes made by some other people. And I would recommend to use live infrastructure monitoring. Constant tools like Cloud Custodian are good for that. So you just run it. You have another set of policies that check the infrastructure, how it is. They don't check. So you should not only check the manifest. You also should check the production infrastructure there.
Okay, thanks, Roman.